Tonight's video is on the next section. It is still on inverse trig functions, but instead of differentiation is now on integration. Our problems that for this evening are 1 through 29 odd. So first off, there are 3 more, just as there were 4 in yesterday's inverse trig function differentiation. There are 3 more to add to our list. We're now up to 40 that you need to memorize, your derivatives and your integration. And so again, you can see these are for the inverse trig function. That's your inverse of sine, inverse of tangent, inverse of secant. And when it looks like this for integration, then it's the inverse of sine, or the inverse of tangent, or the inverse of secant. And you'll have to know what the a is. So like if that was a 16, the a would be a 4. If what is in here is a 9x to the 4th power, then my x is really 3x. That's what I would put here. Right? This has the square root. This doesn't have a square root. Here order doesn't really matter, but it's a constant and a variable. This one here order matters because of subtraction. This one here, it's reversed, and there's x to the 1st power out here. So this is going to have to sit right next to you when you're doing this. In fact, tomorrow you'll be getting a new handout. The first one I gave you said derivatives and integrals. Now it says all. And you can see it goes through 29, and then it continues through 40. Here are the last 3. The ones that you got yesterday are in here. 1, 2, 3, 4, 5, 6. These are those 6 inverse trig functions. And you'll get a second sheet of paper tomorrow with what they are, just like you did the other day. Okay? Anyways. So a couple of things. Again, it's going to mix up some techniques, not just using these, but it's going to throw in there some different techniques when you do long division, when you might separate the denominator and give it to each of the numerators to simplify, like you did in 51 today on the whiteboards. Be careful you need to denote what the U and the A is in every problem. And I even say that you need to write that out for nearly every problem so that you can keep this straight more than ever. And you'll see, hopefully, here in a moment, I'm going to run through about 5 examples. I decided tonight to work on the evens to keep all the odds available to you. You're going to need lots of practice on this. And this is very awkward. So let's start with the first problem. I'm going to do number 2. So that would be the first even problem. So the integration of 3 over the square root of 1 minus 4x squared. So, in fact, let me take the smaller sheet here. I kept this right next to me when I was doing the work. And so that looks like it's going to model this one here. It's going to square roots the constant and the variable second. So the first thing you want to do is you want to denote what the a is, which is 1, right? It's going to be a squared. What the u is 2x, because when I square it, isn't that where you get the 4x squared? Right? Again, you're trying to match this problem here. And I'm going to go ahead, and the du is 2 dx, which is 1/2 du dx, because I don't have a 2 there. And so I'm going to take out the 3. Here's the 1/2. Replace the dx with the du. And so that will now be u squared, right? Because 2x quantity squared is 4x squared. So you have to be very careful. Very, very careful here. Now, this does exactly match this one here. So what is that? That is number 38. So that happens to be the inverse of sine. So I'm going to figure out what the x is, put it over the a, and plus my constant of integration. So my 3/2 inverse sine or arc sine, and that's the x, right? That's what's in that placeholder, or what's the u is, right? 2x over 1, I don't need to show the 1, plus my constant of integration. Right, so it's what this u would be. That's what goes right here. Let's try another one. So I went and I grabbed number 8. Now this one is following the rule of me saying they're going to throw at you different techniques. So I see x to the 4th power minus 1 over x squared plus 1. Now I don't think long division is going to help me here. I do notice something though. X to the 4th minus 1 is actually a difference of squares. Right? That's x squared plus 1 times the quantity x squared minus 1 all over x squared plus 1. They have that in common. Right? Difference of squares. Now it's just the integration of x squared minus 1. So goes to the 3rd power, divide by 3, minus x plus c, I'm done. So I didn't even use anything from today's lesson. They're throwing some of that right in the middle of this. Not a lot, but they are. Let's try another problem. I'll try to stay focused on today's lesson and not just show you how they're doing different techniques. I just wanted to drop that in there. Number 10, the integration of t over t to the 4th power plus 16. So let me get my sheet, handy dandy sheet, see which one is going to start to model. Well, it's not these with this square root, it's going to be modeling this. And again, it doesn't matter about the order. So it looks like my a is going to be 4, right, because 4 squared is 16. And my x, or my u, substitution that I'm going to make is t squared. Because t, if I put t squared in there and square it, that's going to be t to the 4th power. So the first thing I want to do is write that u equals t squared and a equals 4. I'm going to go ahead and take the derivative. So that's how I'm going to take care of that t. 1/2 du equals t dt. So now let's go ahead and let's substitute. So that's already taken care of. Replace it with 1/2 du. That's 1 over u squared plus 16. So this now exactly looks like this one. So what is that? 39? That is the inverse tangent. So I'm going to do 1 over a. My a I said was 4. Arc tangent of what is my x? It's t squared over 4. So I have my 1/2 and my 1 over a. I said my a was 4. Arc tangent or inverse tangent of whatever this u is, right? T squared over 4 plus my constant of integration. Let's try another problem. I have 2 more. There we go. It's number 12. It's the integration of 1 over x times the square root of x to the 4th minus 4. This is not too bad. Looks like it's trying to model this last one, right? So it looks like my a might be 2, and my u is going to be x squared, so that I can get it to look like this. Let's see what I get. I said my u is x squared, my a is 2. So du equals 2x dx. 1/2 du equals x dx. Except my problem is the x is not in the numerator position. That's x times dx. It's not there. What do? Well, I force one to be there. I'm going to multiply the top and the bottom by x over x. This is now x, and this is now x squared. That's all I did here. I just multiplied top and bottom, numerator and denominator, by x over x. So now let's apply this. This x dx can be replaced with 1/2 du, and then this u will go here, and this u will go in here. So watch what happens. Right, there's my 1/2. Here's my u. This is replaced out, and this is now u squared minus 4. Now let's take a look at that. Isn't that modeling number 40? Right? It's completely modeling number 40. And what is that? Let me get my answer sheet. I had it here just a moment ago. There it is. And is my inverse secant. So let me 1 over a. What is a? My 2. Inverse secant or arc secant over the absolute value of u. What is u? It's x squared over 2 plus my constant of integration. So let's go and let's do that. There's my 1/2. It said 1 over a. My a was 2. Arc secant. And then my x squared over 2 plus c. Just multiply my 1/2. That's 1/4. This last one's a pretty interesting problem. It's another one where I have to force it to work just like I did in number 12. This will be the last problem of the evening. Number 20, integrate x minus 2 over x plus 1 quantity squared plus 4 dx. So let's try to figure out what I might do. I'm going to guess it looks something like this. My a squared, that a would be 2. My x is all the stuff inside x plus 1. Let my u equal x plus 1. So I don't know how I'm ever going to get rid of that. Well, let me see what I have. U equals x plus 1 and a equals 2. And when I do my derivative of both sides, it's just going to say du dx. So I'm not going to get rid of that. I mean, I'll be able to write u squared here, but it's just not going to go away. So what I'm going to do is I thought about, what if I have this be x plus 1? The reason being is, what if I have to take all of this to be u? Because that's a different technique. What if u was x plus 1 quantity squared plus 4, du equals, bring down the 2, first power, inside this be 1, and that would be 0. And so I could put the 2 on the outside. So if that numerator would have been an x plus 1, I could have taken the u of everything and maybe just not even use tonight's new inverse trig by integration. I would just use a different technique. I just wish I had an x plus 1 in the numerator. Well, why not force it to be? Can't I say that x plus 1 minus 3 still equals x minus 2? Right? That's what I have. I want this, and if I just subtract 3, I still get my same thing. So I'm going to rewrite this into this. This is this. So let me do that for you. Right? And so I broke it up. X plus 1 minus 3 is the same thing as x minus 2. I just went ahead and put the x plus 1 here, right, because I would like it gone. When I take the u substitution of the entire denominator, and I put the minus 3 over this. This I can now handle. I can actually line it up with this one here, because I can just take out that negative 3 and it looks just like this. So watch what happens. In fact, let me turn this around. So I have my u substitution for this problem. I've already done this, right? The u substitution of everything in the denominator. So there's my 1/2. I'm going to replace my x plus 1 dx with 1/2 du, and that's 1 over u. That piece is done. I'm going to take out that minus 3. Well, let me come back up here, finish this. Right? Isn't that what that is? And so I guess I didn't really write that. Let me rewrite that piece, just this piece here. So I'll take out the negative 3, 1 over u squared plus 4 dx. This is this. And what is that? Inverse tangent. its inverse tangent. So I take out the -3, and the inverse tangent says 1 over a. My a is 2. Inverse tangent, put whatever the u is, x plus 1, over my a, which is 2, my constant of integration. So I've got this piece done. Let me just go ahead and finish this. What is that? That's natural log, right? The natural log, I'm going to put u, but I'm going to put that and resubstitute it back in. I'm going to put these two pieces together, but I think what I'm going to do is I'm going to multiply that out and gather up the 4. So that's x squared plus 2x plus 1 plus my 4, and that's just rewritten. And now I'm done. I added my 1 and my 4. That's all I can really do to that. Thank you.